Here's some examples of some problems involving naming polynomials. So one kind of problem you might encounter is for you to give an example of a polynomial that fits a certain name. So if I have a cubic binomial, right, cubic refers to the degree, that is the name for a degree of 3. Binomial refers to the number of terms, and that means you have 2 terms. There are an infinite number of answers here. You could do any combination of things. I just need my highest exponent to be 3. So I'm going to say 4x cubed, and then I'm going to say minus 2x. That is one example of a cubic binomial. You could do something completely different and say, well, what if I had 2x cubed, oops, it's got to be a 3 though, plus x squared is another example of a cubic binomial, as long as the degree is 3 and it has 2 terms. A quintic trinomial has to have a degree of 5 and it has to have 3 terms. So if it has a degree of 5 and 3 terms, we would say that it is 7x to the 5th is one example, plus 2x squared minus 3. That's one example of a quintic trinomial. It has a degree of 5 and 3 terms. You could do something totally different and say, well, what if I had negative x to the 5th plus x minus 27. It's another example of a quintic trinomial. Okay, the last example here is a quadratic monomial. Quadratic refers to something with a degree of 2. Monomial means it has 1 term. So something with a degree of 2 and with 1 term would be something like 5x squared. That's one example of a quadratic monomial. Another one would be maybe negative 7x squared. It's another quadratic monomial. When you are dealing with certain degrees, you should have a good idea of what their shape looks like. So if I wanted a polynomial of degree 0, I would say, well, I have some polynomial. If it has a degree of 0, then the highest exponent that the polynomial can have is 0. So say I have 4x to the 0. Remember that x to the 0, anything to the 0 is really just 1. So this is the same as 4. Okay, and if you have a graph that is just one number, we say that that's a constant graph. All right, they're saying all the y values are 4. So this is the same as a horizontal line. Okay, and this horizontal line would be at y equals 4. Right? But if I had p of x equals 7, then this horizontal line would be at 7. Okay, but a constant polynomial is a horizontal line. A polynomial with degree 1, all right? So say I had s of x, and degree 1 is just 3x to the 1st, maybe, plus 2. So we could write this x to the 1st, or we don't have to, right? If you have x to the 1st, sometimes it won't be written. Sometimes it'll just say 3x. All right, 3x plus 2 should look familiar to us. 3x plus 2 is a line. Okay, if we were in Algebra 1, we'd say, oh, we start graphing that line at 2, and we go up 3 over 1, up 3 over 1, down 3 over 1. So 3x plus 2 looks like this. Okay, anything with a degree of 1 is a linear function, and the reason it's linear is that it forms a line. Polynomial of degree 2, well, let's call that r of x. Okay, degree 2 is something like x squared plus 1. Well, once we start squaring something, then what we're forming is a parabola. All right, so these are all functions you've seen before. X squared plus 1 looks like this, all right, where this vertex falls on y equals 1. So the shape of a polynomial of degree 2 is a parabola.